Okay, for the very last example, we're still graphing two cycles of the function, and this time we have y equals 4 sine 2x minus 90 plus 2. So one thing to recognize is immediately the coefficient of x is not factored out, so I'm going to do that first. So I would get y equals 4 sine of 2 bracket x minus 45 degrees. So you want to make sure that you factor out the coefficient of x to ensure that your phase shift is what it's supposed to be. Alright, so let's start with the period and the amplitude of the function. And so the period of the function is 360 over k, and so our k value in this case is 2. So the period of the function is 180 degrees. So that will be the horizontal length of one of the cycles. And that makes sense because the graph should be horizontally compressed by a factor of 1/2. And then the amplitude is going to equal to 4 since it's been vertically stretched by a factor of 4. And remember that the amplitude tells you what the max and min values are going to be. So the max is going to be at positive 4 and the min should be at negative 4 since it's been stretched by a factor of 4. And the other thing you want to remember too is because the graph is being shifted up 2 units, then our max value is going to increase and our min value is also going to increase by 2. Okay, so those are just some things to remember, especially when you are just sketching your graph. So I need to ensure that when I do set up my scale here, that I set it up so that I do include the shift up 2. Also, because I'm going to be shifting the graph to the right 45 degrees, I want to make sure that I have some extra space on the right hand side here so that I can shift my entire graph to the right 45 degrees. So one cycle of the graph is 180 degrees. I'm asked to graph 2 cycles of the graph, so let's say this is 180, and so that would mean this is about 360, and I made sure to leave some extra space on the side here. And so one cycle of the graph should go between 0 and 180. So what I'm going to do is split it up so that I have my 5 key points. So split it in half and then split it in half again. So that would be 90, that would be 45. And what that helps me figure out is what the scale is that I'm going by. So my scale in this case is by 45s. So 45, 90, 135, and then 180. And I'll just draw the little markings here for the second cycle as well. And then I'm going to work on my vertical axis. And so I need to make sure that I go up from at least positive 4 and negative 4 so I can graph the stretch graph. And then I need to leave some extra space so that I can shift the graph up 2 units eventually. So 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So leaving some extra space at the top because I know I will be shifting the graph up. Okay, so what I'm going to do first is graph this function here. So the graph that's been vertically stretched by a factor of 4 and horizontally compressed by a factor of 1/2. And luckily the way we've set up our scale sort of incorporates both of those transformations. So we are looking at a sine function, which means I need to start at a 0 and end at a 0, and I have a 0 in between. And between the first 2 zeros I should have a max, and between the last 2 zeros I should have a min. So here's the first cycle of the sine function that I'm looking at. And I didn't do a very good job sketching the curve here, so I'm just going to fix that up. And then same thing for the second cycle. It should start at a 0, end at a 0, have a 0 in between, and then have a max between the first 2 at 4, and then a min between the last 2 at negative 4. And then I can just sketch my curve from there. Okay, so there's the graph that I'm going to be looking at. Now the difference here is I still need to do a phase shift with this. And so I need to actually move my graph to the right 45 degrees and then up 2 units as well. So because I'm going to be shifting the graph to the right 45 degrees, I actually need to add another scale unit. And luckily my scale is already going by 45, so all that means is that I need to move this up to 405. So adding 45 to that is going up to 405. Similarly, because I'm shifting the graph up 2 units, I also need to extend my scale here and make it go up to 6. So what I'm going to do is shift each of my points to the right 45 degrees and up 2. Now choose which points you want to move first, whether it's the maximums, the minimums, or the zeros. I usually like to move the zeros first because when I shift it up 2 units, I'm expecting all my zeros to be along the line y equal to 2. So I'm expecting all my zeros to be across 2 since I'm shifting them all up 2 units. So what I'll do is start with my first 0. I'm going to move it right 45 and up 2. Second 0, move it right 45 and up 2. Third 0, move it right 45 and up 2. Fourth 0, up right 45 and up 2. And then the last 0, move it right 45 and up 2. So they should all form. You'll notice that all the zeros have shifted up to 2. That's where the new line, the equation of the axis would be. So this is where the axis is actually moved for the sine function. Now I'll move my maximum point. So I'm just going to move it to the right 45, and it's going to go up to a maximum of 6. Move it to the right 45 and move it up to a maximum of 6. So far now I've taken care of the zeros and the maximums. And then finally the minimums. And you should notice that your maximum should be halfway between your zeros, just like they were here. And then so your minimum should be halfway between your zeros as well. So I'm going to move this to the right 45, and I'm moving it up to -2 instead of at -4. Again, same thing, right 45 and then up to -2. And you should follow the same pattern. So where the zeros used to be max, 0, min, 0, max, 0, min, and then back to a 0. And then just sketch a curve through your points. And there you go. Okay, so there is your sine function vertically stretched by a factor of 4, and you can see that because the distance between the zeros and the max and the zeros and the min are both 4 units. The horizontal length of one cycle is 180 degrees, so from 45 to 225. The graph has been shifted to the right 45 degrees, so the first point that I used to have here has moved to the right 45, and it's been shifted up 2 units, which is there. So the initial point here should correspond to the phase shift and the vertical shift that you had before. Now, just as an extension, if you're asked to state the domain of this function, if you're only asked to state the domain of the part that you're graphing, the minimum value I have for x is 45 and the maximum value I have is 405. So I would say x is an element of all real numbers such that 45 degrees is less than or equal to x, which is less than or equal to 405. And for the range, my minimum value for y is -2 and my maximum value is 6. So I would say -2 is less than or equal to y, which is less than or equal to 6.